Hello, good evening students. Welcome to this video segment. I am Samuel Chukwuemeka. In this video segment, we shall finish what we started, modular inverse part 2. Please, before you begin this video segment, I encourage you to view the video on modular inverse part 1. Okay, because we are going to use that knowledge to come here to work on this. We are going to solve the remaining two problems from the first video, modular inverse part 1. All right, so number 3, we want to find the inverse of 55 mod 89, right? So the first thing we want to do is to make sure that they are relatively prime, and relatively prime means that their GCD will be equal to 1, right? So we want to find the GCD of 55 and 89. Of course, that's the same thing as the GCD of 89 and 55. Right? Now, just quick notes on what we want to do. Just to remind me, I know that GCD of A and B is the same thing as GCD of B and R, right? And we also have that from our Bezout coefficient, that a GCD of A and B is MA plus NB. Right? And this is the Bezout identity. Okay? I hope we did this in the first video. Alright, so we have that 89 is equal to 55 times 1 plus 89 minus 55 is what? 9 minus 5 is 4, 8 minus 5 is 3, right? And then we bring down here 55 is equal to 34 times 1 plus 5 minus 4 is 1, 5 minus 3 is 2. Then 34 is equal to 21 times 1 plus 4 minus 1 is 3. 3 minus 2 is 1, 13. 21 is equal to 13 times 1 plus 11 minus 3 is 8, right? Then 13 is equal to 8 times 1 plus 5. 13 minus 8 is 5. Okay, we continue here. 8 will be equal to 5 times 1 plus 3, because 8 minus 5 is 3. And then 5 will be equal to 3 times 1 plus 2, then 3 will be equal to 2 times 1 plus 1, right? And then 2 will be equal to 1 times 2 plus 0. So when it reaches at 0, the GCD is now 1. So our GCD is 1. GCD of 55 and 89 is now 1. So they are relatively prime, okay? they are relatively prime. So what we want to do now is to find the inverse of 55 mod 89 by working backwards. All right. So I'm gonna leave this, but I'll leave a space here. So I'm just gonna erase this. I know the next one is 89 mod 232. So what I will do is I will write my question here, that A is 89 and M is 232. That's number 4 question. All right, so let's finish this up. I will need this space, that's why I'm erasing it. So we work backwards, and as we work backwards, we find that in any case we want the dividend and the divisor to be there as we work backwards. Like I said in the first video, right? We want the dividend and the divisor to always be there as we work backwards. And then on the last case, in the last case, we want the dividend and the divisor to also be there, 89 and 55, right? Okay, so as we work backwards, we don't need this. Actually, we start from here, right? So we'll have that 1 is equal to 3 minus 2 times 1, right? And this is equal to, let me just make this space here. 2 is the remainder here. So this is 3 minus 2 is 5 minus 3 times 1 times 1, right? Okay, remember we want the dividend and the divisor. Like here is 3 and 2, we want it to be there, which we've done, 3 and 2. The next one is 5 and 3, right? Dividend and divisor. So we are going to make this to have 5 and 3. Then the next one will be 8 and 5. We want to make sure that the dividend and the divisor is always there, right? So we always simplify expressions based on that. Let me repeat. We solve for the remainder, right? We solve for the remainder, and as we solve for the remainder in each case, we want the dividend and the divisor to be in the equation. As we simplify that equation, we want the dividend and the divisor to be there. Okay, so we start from this step. And when we start from here, we see that 1 is equal to 3 minus 2 times 1. In this case, the dividend is 3 and the divisor is 2. So 3 and 2 is already there. The next case, we want to solve for the remainder, which is 2. So we will substitute. Okay, we will make 2. We will express 2 in terms of 5, 3, and 1. We make 2 the subject of the formula. We solve for 2, the value of 2. And we express it in terms of the dividend and the divisor. The dividend is 5 here, and the divisor is 3, right? So the next case, we will solve it in terms of 8 and 5, because the dividend is 8 and the divisor is 5. The next case will be 13 and 8, then 21 and 13, and so on, until we get to 89 and 55. That is the principle of solving backwards. Okay, so let's express this. This is now 3 minus 5 times 1, then minus times minus is plus, 3 times 1 times 1. So let's get all the 3's together. This is now 3 plus 3 times 1 plus times 1 minus 5 times 1, which is now 3 plus 3 times 1 minus 5 times 1, which is 3 into 1 plus 1, right? Because this is like 3 times 3. 3 times 1 is 3. So this is 3 plus 3 minus 5 times 1, which is 3 into 1 plus 1 minus 5 times 1, which is 3 times 2 minus 5 times 1. So we've expressed it in terms of 3 and 5, or 5 and 3, the dividend and the divisor. Okay? So, and that is equal to, then the next one, we now solve for this remainder that is 3, we solve for it, we express it in terms of 8 and 5. Okay, so the 3 is now 8 minus 5 times 1, then times 2 minus 5 times 1. So this will be 8 times 2 minus 5 times 1 times 2 minus 5 times 1, which is 8 times 2, right? Minus 5 times 2 minus 5 times 1. So I'll bring it over here. I'll bring it over here. 8 times 2 minus 5 times 2 minus 5 times 1, which is 8 times 2 minus 5, 2 plus 1, right? Which is 8 times 2 minus 5 times 3. I'm kind of breaking it down. Okay, I'm kind of breaking it down. So, and in each case, if you do 16 minus 15, it gives you 1. So we've expressed it in 8 and 5. So the next thing is 13 and 8. And the 5 we solve for it, right? The 5 that is the remainder. So this will be 8 times 2 minus parentheses 13 minus 8 times 1 times 3, right? Which is now 8 times 2 minus 13 times 3 plus 8 times 1 times 3, which is 8 times 2 minus 13 times 3 plus 8 times 3, which is, we bring the 8s that are common, right? 8 times 2 plus 8 times 3 minus 13 times 3, which is 8 into 2 plus 3 minus 13 times 3, which is 8 times 5 minus 13 times 3. Right? So we've expressed it now in 8 and 13. The next thing is to express it in 21 and 13. And then we solve for 8. And then we solve for 8. So I'm going to, if you don't mind, you might want to take this down. If you've understood up to this, I'm going to begin. I'm going to erase this, okay, so that I can have some space. So the next thing will be we have 8 times 5 minus 13 times 3, and that will be equal to, now we now solve for 5 because we've got 8 and 13, right? Okay, we just solved for 5 to give us 13 minus 8 times 1. So the next thing is we solve for 8 to give us 21 minus 13 times 1, then times 5 minus 13 times 3. And that will give us 21 times 5 minus 13 times 1 times 5 minus 13 times 3. Right? Probably let me come over here. So, and that will be equal to 21 times 5 minus 13 times 5 minus 13 times 3, which is now 21 times 5 minus 13, 5 plus 3. Right? Okay, so this will now give us what? 21 times 5 minus 13 times 8. Right? Alright, so we've expressed it in 21 and 13. The next thing now is to express it in 34 and 21 as we solve for 13. Right? And 13 is equal to 34 minus 21 times 1. So this will now be 21 times 5 minus 13 is what? 34 minus 21 times 1, then times 8. Right? So this will be equal to 21 times 5 minus 34 times 8, then minus times minus is plus, 21 times 1 times 8. Right? So this will be equal to 21 times 5 minus 34 times 8 plus 21 times 8. So we bring the like terms 21 together. We bring the like terms 21 together. So this will be equal to 21 times 5 plus 21 times 8 minus 34 times 8. Right? So this will be equal to 21, 5 plus 8 minus 34 times 8, which is 21 times 13 minus 34 times 8. And in each case, if you kind of multiply it and subtract, you know, you want to, when you're solving this, you want to kind of do some checks along the way to make sure that when you subtract it, it gives you 1, you know. So if we have 21 times 13, 21 times 13, this is 63, and this is 21. That gives you 273. And then 34 times 8, this is 32. And this is 27, 272. So 273 minus 272 still gives you 1. Remember, 1, we started with 1, the GCD. So you want to, as you do it, to kind of also check periodically, you check once in a while to make sure that you're in order, right? And this is equal to, now, we've done it in 21 and 34. So the next thing is to express it in 55 and 34 as we solve for 21. So this will be 55 minus 34 times 1 times 13 minus 34 times 8. And if you notice this, you know, if you notice the flow, it works periodically, like it works in sequence, like the first one might walk to the right, the next one, this one walk to the left, this one walk to the right, next one will walk to the left, you see? I mean, it's a sequence, you know, that's the interesting thing about it. So this is equal to 55 times 13 minus 34 times 1 times 13 minus 34 times 8. So this is 55 times 13 minus 34 times 13 minus 34 times 8. I try to keep it in twos, you know, keep it in twos always. Two numbers, the product of two numbers, you know. So this is 55 times 13 minus 34 parenthesis minus 34 parenthesis 13 plus 8, right? So this is 55 times 13 minus 34 times 21, right? Okay, so we've expressed it in 55 and 34. Okay, so the next thing, you see this one is like left, the next one will be right. So we have to solve for 34 and express it in 89 and 55. Okay, and I will prefer to do it right here. I'll prefer to do it right here. So we have 55 times 13 minus 34 times 21, right? So this will now be equal to 1 expressed in 34. So this is 55 times 13 minus parenthesis 89 minus 55 times 1 times 21, right? So this will be equal to 55 times 13 minus 89 times 21 plus 55 times 1 times 21, right? So this will be equal to 55 times 13 minus 89 times 21 plus 55 times 21, right? So I get the 55s, the like terms. So this is now 55 times 13 plus 55 times 21 minus 89 times 21. So this is 55 into 13 plus 21 minus 89 times 21. Okay? So this will now be 55 times 34, right? Minus 89 times 21. So we've now, you know, with the Bezo's coefficient, Bezo's identity, now we can now, it's easier to now find the inverse of that. So assuming I erase this, we now see that, of course, this is 55 times 34 minus 89 times 21. Now, remember, with Bezout's coefficient, of course, the GCD of A and B will give us MA plus NB, right? Where M and N are the Bezout's coefficients. Okay, so in this case, GCD of 89 and 55 is now 55 times 34 minus 89 times 21. Okay, we will, we have to get this in order to look like this, because here A is 89 and B is 55, right? So this will be, we have to make this to look like this, okay? This is negative 89 times 21 plus 55 times 34, right? So this is, the 89 is not negative. We can't have the dividend to be negative, nor the divisor to be negative, no. So this is now negative 21 times, you can, first of all, if I break it down, 89 times negative 21 plus 34 times 55, right? So this is now negative 21 times 89, right? Plus 34 times 55. So we see we have the Bezout's coefficient to be negative 21 and 34. And if you kind of, multiply this and subtract, it's going to give you 1. Okay, we can do it. If we do it, 34 times 55, 5 times 4 is 20, 5 times 3, 15 plus 2, 17, 5 times 4, 20, 5 times 3, 15 plus 2, 17. So 0, 7, 1, 8, 7, 8, right? And then when we do 89 times 21, 89 times 21 is 89, 2 times 9, 18, carry 1, 2 times 8, 16 plus 1, 17. So 9, 6, 8. 1869. So negative 1869. Negative 1869 plus 1870 will still give you 1. So we see that the inverse of 55, therefore, the inverse of 55 mod 89 is equal to 34. That's it. Now, it's going to take you time, but you need to do it step by step in order to get it right. I mean, it's something that you need to do step by step. Now, we have an easier way to do this called the extended Euclid algorithm. So I'm going to teach that in the next video, how to find modular inverse using the extended Euclidean algorithm. Yeah. And as usual, like I said, you can check on my website. I place some links to calculators. So you can verify this answer using the calculator links on my website. Okay? Alright, let's do the second question. Let's do the second question. So let me erase all this stuff. Okay. Question number 4. Kind of draw this here. Question number 4 is find the inverse of 89 mod 232. So, in this case, we want to first of all make sure that the 89 and 232 are relatively prime. And what do we mean by relatively prime? It means that the GCD of 89 and 232 should give us 1. I don't know what it is, so let's see. So we have that GCD of 89 and 232 is the same thing as the GCD of 232 and 89, right? So 232 will be equal to 89 times what? To save time, I use my simple calculator, adding machine to save time. 232 divided by 89, that gives us 2.6 something. So 89 times 2, I take the integer part. Which is 2. Then you do 89 times 2, of course 178. Then you do 232 minus 178. Right? 232 minus 178. Okay, gives you 54. Right? So you bring down 89 again, 89 and 54. Remember, with our theorem, please, if you are confused on how I am solving for the GCD, I did 2 videos on how to find GCD using Euclidean algorithm. You have to view those videos as well. Okay, so 54 times 1, of course, plus 9 minus 4 is 5, and 8 minus 5 is 3. Then we have 54 is 35 times 1 plus 14 minus 5 is 9, and 4 minus 3 is 1, right? So 35 is equal to 19 times 1 plus 15 minus 9 is 6, right? And 2 minus 1 is 1, right? 19 is equal to 16 times 1 plus 3, right? Okay, making sure. So 19 is equal to 16 times 1 plus 3. Then 16 is equal to, let me kind of come here, 16 is equal to 3 times 5 plus 1, right? 3 is equal to 1 times 3 plus 0. Right? So the GCD is what? 1. Okay, just double checking, it's always good to double check so that you don't make any mistake. And of course, you can verify this using the GCD calculator on my website, or you can also use TI Inspire. TI didn't pay me anyway. So, but anyway, let's continue. Now, let's go ahead now and start working backwards to find the inverse, okay? So, we work backwards. 1 is 16 minus 3 times 5, and that is equal to, we get 3 to the remainder. As remainder, we express it in that 19 minus 16 times 1, then times 5, right? So this will be equal to, I want to make sure I'm not blocking, 16 minus 19 times 5 plus, because minus times minus is plus, 16 times 1 times 5, which is 16 minus 19 times 5 plus 16 times 5, which is 16 plus 16 times 5 minus 19 times 5. Get the like variables. Well, like numbers in this case, not variables. Like constants. So this is now 16 plus 16 times 5 minus 19 times 5, which is 16, 1 plus 5 minus 19 times 5, which is 16 times 6 minus 19 times 5. Right? So the next one will be to express it in, we've done that of 3. Next one will be expressed in 16, which is the left part. So this is now 35 minus 19 times 1 times 6 minus 19 times 5, right? So this will be equal to 35 times 6 minus 19 times 1 times 6 minus 19 times 5. Okay? It's raining outside. I hope you can hear me. I hope you can hear me. Okay? Let's continue. Okay, so this will be equal to 35 times 6 minus 19 times 6 minus 19 times 5. Right? So which is 35 times 6 minus 19, 6 plus 5, which is 35 times 6 minus 19 times 11. Let's kind of check this to see whether we are on the right track. 35 times 6 will be 6 times 5 is 30, carry 3, 6 times 3, 18 plus 3 is 21. And 19 times 11 is 19, 209. Okay, 210 minus 209 will give us 1. Okay, that's fine. So I will start from here now so that you know. This is now 35 times 6 minus 19 times 11, which is, I've done that of 16, right? So I'm going to do that of 19, which is now 35 times 6 minus 19 is 54 minus 34, 54 minus 35 times 1 times 11, right? Which is 35 times 6 minus 54 times 11 plus 35 times 1 times 11, right? Which is 35 times 6 minus 54 times 11 plus 35 times 11. Okay? Which is now, let's get the like terms together. 35 times 6 plus 35 times 11 minus 54 times 11, which is 35 into 6 plus 11 minus 54 times 11, which is 35 times 17 minus 54 times 11. Okay? So we continue, we solve for 35 next. I've got to clean this, okay? So we stopped at 35 times 17 minus 54 times 11, right? So we've got to do for 35, which is 89 minus 54, right? So this is 89 minus 54 times 1 times 17 minus 54 times 11, right? So this is 89 times 17 minus 54 times 1 times 17 minus 54 times 11, right? So this is now 89 times 17 minus 54 times 17 minus 54 times 11, which is now 89 times 17 minus 54, 17 plus 11, right? So this is what? 89 times 17 minus 54 times 28. Okay? And then we have one more step. Alright, so the last place we stopped is 89 times 17, 54 times 28. Okay? So we solve for 54, right? And that is 89 times 17 minus 54 is 232 minus 89 times 2, then times 28. So this is 89 times 17 minus 232 times 28 plus 89 times 2 times 28, right? So this is now 89 times 17 minus 232 times 28 plus 89 times 56. Get the 89s together. So this will be 89 times 17 plus 89 times 56 minus 232 times 28. Okay? So this is now 89, 17 plus 56 minus 232 times 28. Okay? And this will now be what? 89 times 7 plus 6 is 13, 1 plus 1, 2 plus 5, 7, minus 232 times 28. Okay, we now, I would like to erase this so you can see it clearly to finish this up. I might finish it up there. We now want to go from here to find the inverse of 89 mod 232. So, probably when I erase this. So let's kind of write this in a Bezout, let's write the Bezout identity. Of course, Bezout identity is GCD of A and B is MA plus NB, where M and N are the Bezout's coefficient. So GCD of 232 and 89 is N times 232 plus N times 89. So we found it to be 89 times 73 minus 232 times 28. Let's put it down this way. Let's do that. So this will be 89 times 73 plus negative 232 times 28, which is now negative 232 times 28 plus 89 times 73. Of course, this cannot be negative, like I said. This is now negative 28 times 232 plus 73 times 89. So you see, let me break this down further. This is now 232 times negative 28 plus 89 times 73, which is now negative 28 times 232 plus 73 times 89. So we see 73 and we see negative 28. These two are the Bezout's coefficients. And if you multiply this and subtract, when you do this, you'll get 1 as a GCD. So we can now say that the inverse of, therefore, the inverse of 89 mod 232 is equal to 73. The inverse of 89 mod 232 is equal to 73. Okay? If you have any questions, please feel free to ask questions on the YouTube, as a comment, or email me, whichever, okay? You can find this calculator links on my website. If you just go to google.com, just type in my nickname, Samdom for Peace. That's my nickname. Single word, all lowercase. It's not for. If you type in FOR, it goes to my website, right? The first link. If you type in number 4, Samdom for Peace, it goes to my YouTube channel, the first link. So if you type in this FOR, it goes to my website, first link. If you type in number 4, it goes to my YouTube channel. That is it, and we are done. Thank you so much, students, for listening, and you have a good evening.